بسم الله الرحمن الرحيم. النهاردة هنتكلم عن Lembel Ziv 78 coding. Lembel Ziv 78 coding is a type of coding algorithms that are source coding used for compressing data. It is adaptive coding algorithm, which means that coding is running with generating the data instead of waiting until the data is completed and computing all the probabilities of the data and then encoding them like static coding algorithms do. Lembel Ziv is adaptive coding algorithm. Up to 70s, the whole effort was working on adaptive Huffman coding, but in 1977, Lembel and Ziv are innovated a new code which used for adaptive coding. Their idea based on making a dictionary that contains all the past symbols or streams of characters that are already encoded in the file. It inserts one or multi-character, non-overlapping, distinct patterns of the message to be encoded in a dictionary, which means that each pattern is in the form C node C1 up to Cm. It may be only one character, C node, and it may be two characters, C node C1, and it can be multi-character from C node to Cn. The prefix of each pattern starts from C node to C of n-1, which means that inserting a new pattern is based on a previous pattern. The previous pattern will be the prefix of the new pattern, and the complete of the new pattern is only one character. We have three options to encode the character based on its encoding and its process of encoding. For example, if one character isn't in the dictionary, it will be encoded like that, 0 and the character, which means that that new pattern have no prefix before it. It is a new pattern, consists of only one character. But if the new pattern has a prefix already in the dictionary, so the new pattern will consist of the previous pattern, which is in the dictionary, plus the last pattern character, the new character added to the previous pattern to make a new pattern. The third option, that if the last input character or the last pattern is already in the dictionary, therefore we encode it by adding the dictionary prefix in the previous pattern and nothing added to it because it is already in the dictionary. Let's see an example for Lembel Ziv 78 encoding. we have this stream of characters A, B, B, C, B, C, A, B, A, B, C, A, B, C, A, B. We have to encode this stream of characters using LZ78. Let's start by A. This is a new character. There is no A in the dictionary, therefore we encode it by 0. There is no prefix, and the new character is A. And we will give this output an index 1. This index 1 represents the string of A. Then we will encode B. B will be encoded as A because it is a new character and there is no B in the dictionary. We haven't encoded B before. Therefore, the output will be 0 plus B. There is no prefix. And the index for this new output will be 2. And it represents the string B. Now go for the third character B. B is in the dictionary. It was encoded before. Therefore, we can't encode it alone. We will continue adding a character to a string BC. BC as a string is not in the dictionary before. Therefore, we will encode it with. It has a prefix of P. This prefix of B has index of 2. So the prefix is 2 and C, and give this output the new index 3. This 3 represents the string BC. Now go to the next character B. B is in the dictionary. Continue BC. BC is in the dictionary. Continue BCA. It is not in the dictionary. So we have the prefix BC. This BC has the index 3 and A. Therefore, the output will be 3A. The index for this new output is 4, and it represents a string of BCA. Continue to B. B is in the dictionary. Continue BA. BA is not in the dictionary. So we have a prefix B. B has the index of 2 and A. Give it an index 5, and this represents the string BA. Continue. We have B. B is in the dictionary. Continue BC. Also is in the dictionary. Continue BCA. Also is in the dictionary. BCAA, no, it is not in the dictionary. So this new string has a prefix BCA. This prefix has an index 4. So the encoding for this new pattern will be 4 and A, and give it an index 6. This 6 represents a string BCAA. Continue. B is in the dictionary. C is in the dictionary. A is BCA is in the dictionary. BCAA is in the dictionary. BCAAB, no, it is not in the dictionary. We encode it using the prefix BCAA, which has the index 6, and the last character is B, and give it the index 7, which represents the string BCAAB. Now the output of encoding this stream of characters will be 0A, 0B, 2C, 3A, 2A, 4A, 6B. This is another example of Lembel Ziv coding. We add a new hint in this example that the last character or the last pattern in the stream of characters is already in the dictionary. Let's see from the start. B will be encoded 0B and get the index 1. A will be encoded 0A and get the index 2. Then B is already in the dictionary, BA not in the dictionary, so it is encoded by adding the prefix index, which is 1, and the last character is A. Then continue to A already in the dictionary, AB not in the dictionary, so it will be encoded by adding the prefix index of A, it is 2, and B, 2B. Then R is not in the dictionary, so it will be encoded by 0 and R. There is no prefix to this R. Then R is already in the dictionary, RR not in the dictionary, so it will be encoded by adding the index of the prefix. The index of the prefix R is 5, and the last character is R. It will get the index 6 and the string that represent it are R. The last character or last pattern in the string or the stream of characters is A. A is already in the dictionary and encoded before by the index 2. Therefore, it will be encoded by 2 and nothing, because it is the last character in the stream. So this stream will be encoded by 0B, 0A, 1A, 2B, 0R, 5R, and 2 and nothing. This is the third example on LZ78. It's a stream of characters, all of it A. Let's include this funny stream. The first A will be encoded 0A. Then A is already in the dictionary. AA is not in the dictionary. It will be encoded by the index of the first A is 1 and the last character 1A. Then A is already in the dictionary, AA is already in the dictionary, AAA is not in the dictionary, so it will be encoded by the index of AA, which is 2, and adding A is then the output will be 2A. The last pattern, let's see. A is already in the dictionary, AA already in the dictionary, AAA is already in the dictionary. This is the last pattern. There is no adding a character here, therefore will be encoded by the last index is 3 and nothing. Therefore we can see that stream of A characters will be encoded by 0A, 1A, 2A, and 3 nothing. Let's see the number of bits transmitted to check how much compression we have. We checked the first example, which was a stream of characters including A, B, C, and so on. The number of bits that represent this stream of characters would be the number of characters multiplied by 8. This 8 is the number of bits that represent the ASCII code of each character. Therefore, the number of bits that represent this stream of characters will be 144 bits. So let's suppose the code words that we already transmit instead of this stream of characters. We have 0A, 0B, 2C, 3A, 2A, 4A, 6B. We will encode this stream of integers and characters. First, let's see that the characters will be encoded by its ASCII code, which is 8-bit. So each character here will be encoded by 8 bits. For the integer will be encoded by a number of bits depending on its index. If the index is 1, it will be encoded by 1 bit. If the index is greater than 1, it will be encoded by a number of bits equals to log of the base 2 for I. Therefore, for index 1, the code will be 0. It is 1 bit. For the index 2, log of the base 2 for 2 is 1. It will be encoded by 1 bit. It will be 1. For 3, log 2 for 3, it will be greater than 1 and lower than 2. We will approximate it to 2 bits, so its code will be 1 0, and so for its code will be 1 1, and continue adding the codes for the different indexes that we have. Now we can assign number of bits for these code words. We have 0, it will be 1 bit, and A 8 bit, 1 bit, 8 bit, 1 bit, 8 bit, 2 bits, 8 bits, 1 bit, 8 bits, 2 bits, 8 bits, 3 bits, 8 bits. As it is shown here, we compute the number of bits for each code word. When we add all of these bits, we will get 67 bits. So the compression here, or the compression efficiency, would be 67 by 144 bits percent. Okay. Let's see the decoding process for Lembel Ziv. We received this code words as the receiver: 0A, 0B, 2C, 3A, 2A, 4A, 6B. Let's decode these code words. Firstly, 0A, there is no prefix and A, so the output will be A, and get the index 1. This one represents a string of A. 0B, there is no prefix and B, so it will be decoded by B. It gets the index 2 and its string is B. 2C, 2 is a prefix. 2 represents B, so we add B then C, so 2C, it will be decoded by BC and get the index of 3. 3A, 3 represents the index 3, it is BC and A. It will get also the index 4. 2A, 2 represents P, then the decoded word is BA. 4A, 4 is BCA, then 4A will be decoded BCA A and get the index 6. The final code word is 6B. 6 represents BCAA and add the last character B. Therefore, the output for the received code words is A, B, B, A, B, B, C, B, C, A, B, A, B, C, A, A, B, C, A, A, B. This is the original string that is encoded as the transmitter. This is a lossless encoding algorithm. Continue for example 2, which decoded example 2 at encoding. We get 0B, 0A, 1A, 2B, 0R, 5R, 2 and nothing. 0B will be decoded B, get index 1. 0A is A and get index 2. 1A, 1 is B, therefore it will be decoded by BA. 2B, it will be decoded by which 2 is A, therefore 2B is AB. 0R, there is no prefix, therefore it will be decoded by R and get the index 5. 5R, 5 represents R, therefore it will be decoded by R. And finally 2 and nothing, 2 is A, it will be decoded by A. Therefore the output will be BA, BA, AB, R, A. The last example of decoding decodes the third example in encoding. We get 0A, 1A, 2A, 3 and nothing. 0A will be decoded by A. 1A will get 1 is A, therefore it will be decoded by A and get the index of 2. 2A, 2 represents AA, therefore the output will be AAA and get the index 3. And finally 3 and nothing, so we repeat the output which has the index 3, AAA. Therefore the output will be AAA, AAA, AAA. This stream of character A. As we saw, Lembel Ziv algorithm is a lossless algorithm. It is adaptive coding. Thank you for listening and see you at next lecture.